Hello, you're welcome back. All right, so here we are going to be looking at coordinate geometry. Okay, so what is coordinate geometry? Now, as you can see, for here I have a Cartesian coordinate. Okay, and I have a coordinate system which I use two reference axes. Okay, to represent vertical axis y called use of the vertical axis is actually the y axis and the horizontal axis is s axis. I'm very sure that you are familiar with this kind of coordinate system, okay, especially for those of you that have actually drawn graph before. So you represent you actually use graph, okay, where the vertical axis and is used to represent your independent variable, okay, of course, and the horizontal axis is a dependent variable. That is by the way. Okay, so now coordinate geometry actually uses ordered pair of numbers to actually represent a point in a rectangular coordinate. Let me repeat. In coordinate geometry, okay, we use ordered pair of numbers a pair of number in an ordered form to represent a point in a rectangular coordinate. This is exactly what we have. This is an illustration. Okay, here I have the vertical axis, that is y axis. I have the horizontal axis, which of course is the s axis. Okay, so this is the y axis. Let me use capital letter Y to represent that, and of course the s axis. So at each point in this rectangular coordinate, all right, uh, I can represent a point using ordered pair of number in such a way that, as you can see here, the point P, all right, is represented by s coordinate and y coordinate. So that's what happens when you draw a graph. Okay, you want to locate a point in the graph, you trace it to the x, and of course you trace it to the y. For example, okay, let's say you're being given this order pay, right, and that's 2,3. Okay, now this order pay is always what is known as a coordinate. In every coordinate, okay, you will see it's always the very first number there represent x and the second represent y. So it's always in an order, is in an ordered form, right? The first represent x, y the second represent y. So as I was saying, let's say you are being asked to represent 2,3. Okay, of course you have to locate the point, please pardon me, locate the point 2,3 in a rectangular, in a coordinate system. So of course that simply means that you have to trace the point 2 from your horizontal axis, and they have to trace the point 3. So the point where 2 and 3, okay, intersects, that is exactly the point. So the point P is going to be at the point where 2, which of course the s coordinates intersect with 3, the y coordinates. So that is what we do in the coordinate geometry. So I hope that is well understood. All right, so now let's proceed. Now the next thing we're going to talk about here is increment in rectangular coordinates. Increment, or even you can call it change. Increment, okay, um, in rectangular coordinate, or in coordinate geometry in general, is of two types. We have the s increment. S increment is same as the change in x. Okay, so I use theta s to represent it. So we have an increment if there are 2 points. If we have 2 points in the rectangular coordinate, okay, so the difference between the final point, of course the s coordinate of the final point, and the s coordinate of the initial point gives me the s increment. So this is what I call the s increment, or changing s increment. Okay, the same thing also happen with y increment. You do y2 minus y1. Okay, now of course, how do I represent that in a graph? Let's look at a situation where I have 2 points in the graph. All right, okay, let me draw that one. Point A and point B. All right, so let's say point A has the coordinate of x1, y1. This is the very point. Then I have another point, and this is point B in the same, okay, coordinate, rectangular coordinate. This time around, point B is the second point. That's having coordinate of x2 and y2. Okay, so you discover that, let's say this point actually gives me a straight line. Let me join point A and point B, okay, which gives me a straight line. Okay, now I use a different color. Okay, so you discover that for these 2 points, point A and point B, okay, we have okay the different coordinates, s coordinates. For point A, the s coordinate is x1. Then up to point B, the s coordinate, if I trace the s coordinate, that's at this point we have s2. All right, okay. For y coordinate in point A is y1. And if I also trace this y coordinate, okay, is y2. Okay, so you now discover that there's always a difference between x1 and x2. All right, so from this point to this point is what we call the increment in x, the difference between x2 and x1. And of course, the difference, okay, it can also be from here. You can trace it here. The difference between y2, okay, and of course y1 is the increment of y. Okay, so invariably now, let's say for example you are being given a to be equal to 2 comma 3, then and b, another point b, which probably is 4 comma 6. Okay, so if you are to do delta x of this, remember delta x is the final point, x2 minus x1. Okay, and that will give us 4 minus 2, which of course is 2. Then if you want to do increment in y, you're gonna have y2 minus y1. Okay, that's going to be 6 minus 3. That yields 3. Okay, so I hope that is well understood. So that is how we actually evaluate increment in a Cartesian coordinate. Okay. All right, then the next thing we are going to look at is going to be the distance between 2 points. Okay, distance between 2 points in a Cartesian coordinate. So of course, a straight line is being established when I join. Okay, I can establish a straight line when I join 2 points. 2 points in a Cartesian coordinate. Okay, if I join it, it gives me a straight line. So I want to look at the distance between those 2 points, which would serve as the length of that straight line that joins those 2 points. Now let's see how can we actually do that. Okay, let's establish that in a diagram. Okay, so let's say I have 2 points, point P1 and point P2. Of course, point P1 will have a coordinate x1, y1. Okay, that is the initial point. And point P2 has coordinate x2, s2, comma y2. Okay, so you know very well we have established change. Okay, we know that the change, there's going to be a change in x. Okay, and that's exactly what I represent by this I'm using this horizontal line to represent. So this horizontal line represent change in x, delta x. So I'll use a color. Then of course the vertical line, I'm going to use a vertical line joining the 2 points, okay, to represent the change in y. So of course you know very well at this point, okay, this point is the my x2, you know that already, and this point is my x1. So that means from this line now actually represents my delta x. Okay, as you also know, this point for in my vertical is my y1, and the final point here is my y2. So that means the whole of this vertical line, of course, which is parallel to this, represents my change, okay, in y, delta y. Okay, so with what I've actually drawn, I discovered that I have actually created a right angle triangle, vertical and horizontal. Of course, this is 190. Okay, so now the whole idea is for me to find the length of this straight line, or the distance between point P1 and P2. So this right angle triangle has, of course, opposite, adjacent, and hypotenuse. Okay, my opposite is my delta y, vertical the increment in y, that's my vertical line, and of course my adjacent is my increment in x, that is my horizontal line. So now the hypotenuse now is now going to be the distance, the distance of the line joining P1 and P2. Okay, so I use dP1 and P2 to represent it. All right, so now by Pythagoras theorem, if I want to get the distance of that line that join P1 and P2, okay, simple, I'll do the square root of, okay, you know how we do that, the square root of my adjacent, which of course is my delta x. Of course I have to square it, right? Then plus the square of my vertical or y increment. So that is it. Okay, so I can actually write that in full. Already you know that my x increment is gonna be x2 minus x1. Okay, I square that, then plus my y increment is gonna be y2 minus y1. I also square that. Okay, so this is how I get the distance joining 2 points, okay, in a Cartesian coordinate. For example, let's say you're being asked what is the distance. Okay, joining what the distance of the line. Okay, let me put it this way. What is the length of the line? 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 What is the between. Okay, so number 1, a 2 comma minus 1, and b 3 comma 4. Number 2, minus 1 comma 3. Okay, let me call that point C, right? Let me call that point C. And point D 1 comma 5. All right, so it's easy with my formula, right? So number one question, the length of that line joining A and B, of course, using my formula, okay, of x2 minus x1. S2 here is 3, S1 is 2, I square it, plus y2 is 4, y1 is minus 1, so 4 minus into minus 1. I'll square that also, so this is going to be equal to 3 minus 1 is 1, that's going to be 1 squared, then plus 4 minus, of course, minus into minus is plus, that's going to be 4 plus 1. Okay, so 4 plus 1 is 5, so I'm having 5 squared, right? So this is going to be equal to the square root of 5 squared is 25 plus 1, that is 26. Okay, so 26 is the distance or the length of that line. So of course, you can use any unit, right? You can go with any unit. It can be cm, meter, or so if we are dealing with cm, then of course but let me just put it this way in magnitude. So I'm very sure this will be easy for you to evaluate. Let's proceed to the next subtopic. All right, so here now in the next subtopic, we are going to be looking at the midpoint, okay? Midpoint of a straight line. So that is the midpoint of the line, okay? Straight line joining 2 points. All right. All right, here we go. How do we actually get the midpoint of a line joining 2 points? Let's say you have a pointer. Okay, 2 points in the Cartesian coordinate, point P1, okay, which of course we x1, okay, has s1, y1 as the coordinate of the first point, right? Then and the second point P2, okay, you have s2 minus y2. So these are the coordinate of the two extreme points. Okay, the two extreme of the line. Okay, so of course this is P1 of x1 comma y1, right? P2 x2 comma y2. So now we are looking for the coordinate of the midpoint. So I use M of course, mx comma y to be the coordinate of the midpoint. So what we are looking for now is that coordinate of that midpoint, coordinate of the midpoint. Okay, midpoints joining the 2 points P1 and P2. So the coordinate of the midpoint, of course, I use M with coordinate x comma y. How do I get that coordinate of that midpoint? Mx comma y. Simple. All I just need to do is, remember, the coordinate will have both x coordinate and y coordinate. Okay, so in a bracket, the s coordinate is going to be, I'm going to find the s coordinate by the time I find the average. The midpoint between s1 and s2 is going to be equal to s1 plus x2. Of course, you have to divide by 2. That's the midpoint of, okay, that's for the s coordinate. Then for the y coordinate, the same thing goes, y1 plus y2. Then you divide by 2. As simple as that. So that's how you get the coordinate. So for example, let's say you got to have 2 points. Okay, let's say 2 comma 3 and another point 4 comma 2. All right, so you're asked to find the coordinate of these 2 points. Okay, so here goes what you do. x1 is 2 plus x2, which of course is 4. You divide by 2 comma, the same thing goes with y. y1 is 3 and y2 is 2. Then of course divided by 2. So of course you know that will now be 6 all over 2, right? Which of course is 3. Then 5 all over 2. So please take note of the formula, okay? So anytime we are being asked to find the coordinate of a midpoint of a line, a straight line, this is what you use this formula, okay? What if the line is not a midpoint? What is the point? Is the point you're looking for is the point that divides the line into 2 unequal parts. Okay, so that's what you're going to look at now. So let's look at the coordinates. Coordinate of a point dividing a straight line into, okay, to, okay, divide a straight line, okay, into 2 unequal part by ratio, by a straight line by ratio, Okay, so let me illustrate what I mean. Let's say you got a straight line, okay, as usual, with initial point being P1, okay, having coordinate x1, y1, and of course P2 having the coordinate of s2, y2. So now I'm now looking for the points, okay? I can still call it M. Okay, let me call it N this time around. I'll look for a point N, okay, that actually divide this 2 line, but not into equal parts, but into 2 unequal parts of ratio. Let's say ratio of M is to N. Okay, that means the first part should actually have the ratio. Remember, ratio goes in order. Okay, so the first part should be of the ratio m, while the second is should be of the ratio n. Okay, so how do I divide this line by this ratio? Here we go. So that means the coordinate of that point n, which of course with coordinate x comma y that divide the line into this ratio, can simply be solved this way. All right, now remember, the same way ratio is ordered, the same way my coordinate my coordinate is an ordered pair, ratio is also an ordered pair. Okay, my coordinate is an ordered pair, so invariably if I want to divide this into the ratio m is to n, okay, remember I will have x1 plus x2 in an order, right? So that means the very first, okay, ratio m is for the x1. That will be the coefficient of x1, right? Because we are dealing with ratio now, okay? And the n will be what will be the coefficient of x2. Then I have to divide by the total ratio. So this one is for the x coordinate. The same thing with the y coordinate, okay? M for y1, coefficient of y1, and for the coefficient of y2, then divided by their sum, by the total ratio. So if you can remember this, you're good to go. For example, p1 2 comma minus 1, and of course p2. Okay, let's say 3 comma minus 3. Okay, so let's roll with the coordinates. So the coordinate of the midpoint simply is going to be equal to m. Okay, I'm not giving the ratio. Let's say the ratio is 2:3. Because you must be given a ratio for this division, right? 2:3. Okay, so let's flow. Okay. M, of course, m is gonna be 2 and n is 3. So I'm having 2 times 2x1, right? Of course, s1, number s1 here is 2. That's gonna be 2 times 2. 2 times 2, please pardon me. Then plus 3 times s2 is 3. 3 times 3 divided by 2 plus 3, comma. Okay, so for the other one, here we go. We roll. Okay, so that's gonna be 2 times y1. Y1 is minus 1, then plus 3 times y2, which is minus 3. Still divided by the sum, 2 plus 3. Okay, here we go. 2 times 2 is 4, 3 times 3 is 9. 4 plus 9 gives me 13. So the x coordinate is going to be 13 all over 5. What of the y coordinate? Minus 2 minus 9. Okay, that gives me minus 11 all over 5. And that is, okay, my answer. So I hope that is well understood. Okay, I will continue, okay, with some other subtopic. We're definitely going to be looking at we are going to be looking at the intersection or the relationship between two lines, okay, two lines in a Cartesian coordinate. I have been dealing with just one line So there's some cases where you have two straight line, or even when you draw graph, you can draw graph of two different graph in just one Cartesian coordinates. So we look at a relationship between two straight line in a Cartesian coordinate depending on the angle between the two straight lines. So that's what we're going to be looking at in the next video, right? Okay, so see you in the next video. Thank you very much.